Today, TypeScript 3.9 and 3.10 is just released. What do I have for you? Let's talk about it. So the highlight of these two releases is this positive number arithmetics. The type system of TypeScript does not support arithmetic out of the box. So over the years, there are many libraries try to fill in that gap. The typical implementations are based on lookup tables and recursion. So because of that, the actual range you can work on is pretty limited because, well, number one, for the lookup table, you can create an infinite size lookup table. And also for recursion, there is currently in TypeScript 4 a limitation of 64 recursion steps. So the stack can only grow to 64 deep. So because of that, you can't really do arithmetics on large numbers. So in TypeScript 3.9, I came up with an implementation that allows you to work on much larger numbers. So what you can do is something like this. You can do a addition, you can do add or subtract on 5-digit number with no problems. The reason I mentioned 5 digits here is because today TypeScript can only dynamically generate numeric literals using the triples length. So that means if I want to generate a large numeric literals like 7777, I actually need to create a tuple of that size in order to get that number. So because of that, this computation is quite expensive. As you can see here, that if I just generating 4 digits number, it would take 1 second in my laptop. But if I generate 5 digits, it would take 5 seconds. And if I do a 6-digit generations, it takes me 120 seconds. So it grows exponentially. But the good thing is in practice, you typically don't need that large number. So 2, 3, or even at most 4 digits would be sufficient. In general, this would be pretty significant because you don't have to think about the limitations anymore, or it will come up with some weird case that it would cost you a lot of time to debug and try to figure out what's going on. With the ability to add, subtract, and also other things such as calculate, finding out the max, or do a comparison, there is a lot of optimizations you can do in your type level programming. So I hope you will like it, and if you have any suggestions or ideas on how to improve on this, or is there any specific interesting use case, let me know. So another thing I have added is adding 3 new functions in the isType. So as you can see here, before 3.9, when I'm doing type level programming, I need to write a lot of tests, and when I do the test assertion, I use this assert type is true and then pass in the value as true and then cast it to the type that I want to check. This is a little bit verbose. I decided to add these 3 new functions. The first 2 is obvious. You check if it is true, then it will return true, and false return false. If you put in a type that does not evaluate to true, then you will have an error right there. So for this equal function, you can use it as either an equal, which you will specify true, or a not equal, which you specify false over here. Most of the time I find I will just use true. And the reason I have to do this is because I want to provide immediate feedback, and then so I need to have a place to indicate the error. So that is the way that I come up with. And so that if A does not equals to B in this case, then the true will be underlined with an error saying that A does not equal to B. So the same thing over here. If A is actually equal to B, then this false will be highlighted. And then I have also added a bunch of new array manipulation types in this release. They are pretty standard, and some of the other type library have this kind of types and more. I just add some of these in because I need this when I'm doing the arithmetic calculation. So that's why I'm adding them in. If you need specific one, you can let me know. I can just easily add them in. They are not too complicated to add. And what they do are pretty self-explanatory. they have pretty good tests. So they check out all the weird case that, say for example, when you create a tuple with the length is negative number, it will actually show you, you will get an you will get never instead of you get an error in the TypeScript saying the stack size is excessively deep and things like that. Another thing new in this release is that in the type predicates, so say for example over here the example is using hash key, but there are other examples like say for example is array or the equals, can assign, all those types. Now I have added a then and else clause. So that means that you can override it. You can override the behavior. And so say for example like this, the hash key originally it will return true and false. But if you write it or essentially use it like this, then it's actually make it work like a filter, right? So in this case, this is saying, oh, if A has, if this type A have a property named A, then it will return itself. If not, it will return never. So then you can change it up and use that as filtering. Then, and of course, if you want, you can create a type alias yourself for that, say filter hash key, or even filter hash key A, right, to make it reusable. You can also use it like an if statement. In this case, I'm overriding the true case, and if it is true, then it will do this evaluation. And of course, you can also override the else case and do something else. But one important thing to note is that when you're writing the code like this, it makes it more compact and easier to read. But at the same time, you need to be careful. Because this is a custom construct, TypeScript doesn't know that it has to do the evaluation using the first two types before it executes the second one. TypeScript will only see that you have a type and then you are passing 3 values into it. Therefore, you might get some performance hit or even you getting the wrong result. So here is an example. Say I have a type L that it equals to -1, and I want to use this L to create a tuple. Of course, create a tuple with length -1 doesn't make any sense. In the actual implementation, I actually have checked to make sure the L is a positive number. Assume it does not, and so you might want to use this is positive type to make sure the L is positive before you calling the create tuple. However, TypeScript doesn't really know that this is positive type is a type predicate, so it will execute this regardless, and what you will got is this error. Therefore, in this case, you should use this standard syntax instead. Well then, maybe you will question, hey Homer, then why you are adding this? The reason I'm doing this is because down the line in TypePress 4.0, I'm going to consolidate the type predicates and the filter to unify them. So this will provide a way for you to easily convert between the two. So when I'm making that breaking change, it's easy for you to adjust. And the last thing in this is I'm renaming a few types to give it a better name. Say for example now the prop union, which I think I introduced in 3.6 or 3.7. I'm renaming into union of props, and then array value, renaming into union values, and so on and so forth. This map to props it's been around for a while, and I'm renaming it to intersect of props, and also this common keys is renaming to common prop keys. And the old names is still there and is not marked as deprecated because I realized if I mark it as deprecated, if you are using it, and then your CI will break because TypeScript, when you try to compile, it will sort it as a deprecate and mark it as an error instead of as a warning or something like that. So it will fail your build. So because of that, I'm not marking it as deprecate as such right now. And I will be marking it as deprecate when I'm ready to release TypePress 4.0, and then we can fail the CI, and then subsequently I will remove it. And I know the naming is the hardest often is the hardest part of the of programming, and this might not be the best name. And say, for example, this union of values in some other libraries is just called element of, and it's nice and clean, and it might be a good name. So over here right now, I just try to be as descriptive as possible to describe exactly what it does, but is always a point for discussion, right? So well, that's it. That is what's new in Type Plus 3.9, and well, as I mentioned in the beginning, this is about 3.9 and 3.10, and for 3.10 I just add one more function, well, one more type, which is in the math. I also add an absolute ABS types in there. And as always, when I release 3.9, I make a hiccup that I have the subtract type there, but I didn't export it. So that is fixed in 9.10. And so when you get it, well, since it's released, when you upgrade, you probably will get 9.10, and actually 9.10.1 at the time when I'm recording this video. Well, that's it, and hope you will enjoy it, and hope you will able to find good use of these new types that I add in. And as such, that's the end of this video. There's a lot more I can talk about this type, and I'm going to create some more in-depth videos about how they are implemented and the lessons that I've learned, and how can you be better when you're doing your type level programming. So until then, we'll see you next time. Bye.